Okay, I'm going to go over the warm-up just to review some of the concepts that we saw at the beginning of the school year. And I'm going to start with number 1. So remember to put an exponent of 1 on the 7 and the 2. Okay, distribute the exponents. So that gives us 7 to the second, 2 to the second. What is 7 to the second? 49. 2 to the second is 4. Can we simplify? Yes. How many times does a 4 fit into 49? 12 times and 1 left over, so it's 12 and 1/4. Hands, we got that? Okay, good. Number 2. Same idea, except they added a little bit more. Put a 1 there, distribute. We get 10 to the second over 2 to the second. What is 10 to the second? 100 over 4. What is 100 over 4? 25. Bring down the minus 6. What is 25 minus 6? 19. Hands, have you got that? Okay, good. We got this. Go to number 3. Number 3 is a little tricky, but it works. Check this out. Put a 1 there, distribute, and I said that for all negative numbers, you leave them in a parenthesis. Is that correct? Yes. To the second power over 2 to the second. So what is negative 9 times negative 9? 81 over 4. How many times does 4 fit in there? 20 times and 1/4. Hands, have you got that? Okay, good. Go to number 4. Number 4. It says add. But let's say I leave it as a subtraction, because we can change this to the additive inverse by doing the plus minus here. However, look at it. If we have two fractions, what is the very first thing we need to do? Don't look at those, just think of any two fractions. If I ask you to add or subtract two fractions, what needs to be true? They need to have a what? Common denominator. Do we have a common denominator here and here? No. So can I make this into this? By doing what? Multiply times 4a, and of course whatever we do to the numerator, we do to the denominator. Multiply times 4a. So therefore this is 4a over 4a squared minus, this one stays the same, 6 over 4a squared. So now that we have common denominator, we write it only as one denominator, 4a squared. Focus on the numerator. Draw your heart. Aww. Can we combine these two? Guys? No, they're two different things, variables and constants, so I just write it out. 4a minus 6. And for right now, we can leave it like that. Okay? Simple stuff now. Instead of just with numbers, we have to deal with variables. Okay? And last but not least, number 5. This was last night's home plate. Now, for those of you that haven't been keeping up with your methods, we started with the first method last week, which was solving quadratic functions by graphing. Remember that? Made a table, graphed it, and found the solution. Yesterday we covered solving by factoring. Did we do that yesterday? Yes. Today we're moving on to a third method. Okay? Because guess what's coming up? If I give you one equation, I'm going to say in a pop party to do what? Solve how many ways? Let's go. Alright, here we go. So, step 1 is in a standard form. Let's see, do we have from highest to lowest degree on this side? Yes, except for we're missing what? The constant, so I need to subtract 15. Subtract 15. We're left with x squared plus 2x minus 15 equals 0. What's next? Power Rangers, negative 15 and 2. Factors of 15 that add up to 2. 3 and 5. One of them has to be negative, so it has to be the 3. So this is x squared minus 3x plus 5x minus 15 equals 0. Let's group. So we get x minus 3, 5, x minus 3, and all that equal to 0. So my two factors are x minus 3, x plus 5, and all that equal to 0. Are we there so far? Next step, ZPP. Yeah, you know me. So what do I write? X minus 3 equal to 0. X plus 5 equal to 0. So far so good? Alright. From there, solve for x. Plus 3 plus 3. X equals 3. Minus 5 minus 5. X equals negative 5. These are my what? Solution. X-intercept. Zeros. Or roots. Am I done? No. Even though the home plate did not tell you last night to graph, what did I ask you to do? Graph. So therefore, is that crooked or? Yeah, a little bit. There it is. So my roots are 3, negative 5. What is my y-intercept, everyone? Negative 15. So I'm going from left to right. Hands if you got that. Okay, good. Hands if you got all 5 of them. 4. Okay, not bad. Get a Cornell note ready, please. Our objective for today, I can solve and graph quadratic equations by completing the square. Let's read together. 1, 2, 3. I can solve and graph quadratic equations by completing the square. So today we're moving on because this is the third method of solving quadratic equations. Are there only 3? No. There's 2 more methods. So imagine when I give you, like, solve this quadratic equation 5 different ways. Let's go. Bam! Jason for Presidente. Let's go. Alright. So today's method is completing the square. Do we need a Ferrier model for quadratic equations? No, we already know what they are. I gave you guys that yesterday. There are 2 variable equations with the highest degree 2. I gave you guys examples, non-examples, and hashtags. So for today, I'm going to start with, I'm going to turn on my camera here. I'm going to start with using tiles once again to apply it to geometry, so you guys can see the concept at work. So at this time, writing utensils down, look up to the screen. Here we go. I'm going to start off with a polynomial. There it is. Tell your neighbor that polynomial, please. That is correct. We have x squared plus 2x. Now, today's method is called completing the square. Remember the other day that we did factoring and we were doing rectangles, weren't we? Today we're not going to do rectangles, we're doing what? So if I was to make a square out of this, I need to evenly distribute these 2 instead of leaving them together like that. This is the rectangle. I won't leave it like that. I'll split this one up, bring this one down here, and now it starts to look like a square. Is that correct? However, is it complete? No. It's missing stuff. That's why this method is called completing the square. What is it missing? A 1. So if I bring this yellow one right there, then now it's complete. It looks like a square. So what did I add? I added 1. What I just did is called completing the square. I'm using the area model for right now. Alright, let me put this out of the way. Scoop this down. Let me add some more stuff. Tell your neighbor what I have in front of me. X squared plus 4x. That is correct. Alright. And what figure do I need to make with these squares? Can I keep them all together here? No, I need 2 and 2 down here. What would complete this square? 4. That is correct. Positive 4. And let me show you really quick. 1, 2, 3, and 4. And there it is. Yes.
What do you do if it's an odd number of...
We'll get there. But for right now, let me continue like that. So I want us to get the pattern first. All right. Next. Everyone, what do I have? X squared plus 6x. Alright, so that means I'm going to put 3 here and 3 down here. Tell your neighbor how many we need to complete that square. 9. That is correct. We need 9. Are we there so far? Alright, now that we got the hang of this, okay, I'm going to take away this now, and I'm only going to use algebra. And take away those, including my fingers. There it is.
Oh, no.
Alright, here we go. Let's say I gave you x squared plus 10x. Tell your neighbor what we need to complete that square. Everyone? That is correct. 25. Let me do another one. X squared plus 14x. Tell your neighbor what we need to complete that one. Plus 49. Alright. On your paper, I want you to write this down. Example Q. X squared plus 24x. And I want you to complete this square. Complete the square. You do that by yourself. X squared plus 24x. Hold on. You have an answer by now. Isaac. Plus 144. Hands if you got that. Okay, let's do one more of these. Example Super Q. X squared plus 22x. Tell your neighbor what you need to complete that. We need what? Plus 121. That is correct. Do we get the pattern now? Yeah. So now, there is a pattern to be found all the way through. So pay attention. Look up to the screen. Something is happening to get this number. Okay? Think about it. How would you explain what's happening to all of them so we can generalize to get this one? Talk it over to your neighbor, please. What are we doing? Let's see, Luca, what's going on? So you're going to divide the number before x, so the middle coefficient, you divide by 2, and then multiply by itself. What's another way of saying that? To the second power or squared. Let's see if it works. What is 2 divided by 2? What is 1 squared? Let's see if it works. 4 divided by 2 is squared, that's 4. 6 divided by 2 is, what is 3 squared? 10 divided by 2 is squared, that's, yeah, it does work. Okay, so let me give you a challenge one. Here we go. Example NJQ. Okay, here we go. This is what we call standard form of a quadratic equation. Here we go. AX squared, this is an A, plus BX. So, Mr. Q, you don't give me any numbers. I understand. But we still can write something at the end. Talk it over to your neighbor, let them know what would you write at the end to complete that square. Let's see. Get it? Let's see. Mel, go. Plus b over 2 parentheses to the second power. Hands if you agree with that. That is correct. The middle term is always b, and what was the middle term on all these? Different numbers, but now we have a variable, so divided by 2 squared. This is what we call and what we would use to complete the square. Pretty simple? Alright, so let's move on now, and we're going to start with an example, but before that I want you to write steps. Write these steps down, please. It's only 6 steps. I'm trying to crunch them as much as I can. Set the quadratic equation in standard form. Step 2, divide the entire equation by the leading coefficient. Eliminate the constant. Add b over 2 squared to each side of the equation. Factor. Take the square root. Write 2 equations and solve. Copy that, please. Alright. We got the steps, yes? Alright, turn your paper over. We're going to need like a bunch of room, so we're going to start from the very top and copy example 1. Example 1 says, solve by completing the square. Write that down. Check your answer. And then we got x squared minus 6x minus 16 equals 0. Copy that. As soon as you copy that, I'll go over that. Alright, writing utensils down, look up to the screen. I'm going to go through the process. I left the steps here on the side. I wrote them small so we can follow the process and you see how it's going to work out. But I want you to pay attention first, and then I'll have you copy the steps once I ask you to copy. Everybody ready? Here we go. By now, all the process should be able to make sense. Okay? I'm going to start off with the first one. Step 1 says, set the quadratic equation in standard form. Is it in standard form? Yes. Check. That's done. Step 2, divide the entire equation by the leading coefficient. What's my leading coefficient here? 1. Remember last semester when I asked you for polynomials to find the leading coefficient? That was for this purpose. A lot of the practice went in there. Leading coefficient was 1, so I'm going to divide by 1. What do I have left? X squared minus 6x minus 16 equals 0. And I know some of you are thinking, Mr. Q, why if it's 1 do we have to do it if we get the same thing? To build what? Muscle memory. Because what if we get later on a 2 here or a 3 here? I want you to practice the steps. Everybody still following so far? So that was step 2. Step 3, eliminate the constant. Which is my constant here, everyone? Negative 6. To eliminate negative 16, what do? Add 16, add 16. Now check this out. Look what's going to happen. This stays in the same spot, same as that. Here we have a gap because we eliminated the constant, and we have 16 on this side. And I'm done with step 3. So up to right there, copy that please, and then I'll do the next steps once we have those. Copy and go. Right. Does this look familiar? Yes, it's what we did with the tiles, is that correct? But we're missing what? Something here to complete the square. Does everybody follow? Yeah. So we're going to complete the square. That's what step 4 is all about. Step 4 is to complete the square. Or it says, let me zoom in, add b over 2 squared to each side. Alright, so in this case, what is b here? Negative 6. So we're going to add negative 6 over 2 squared. Add negative 6 over 2 squared. Before you copy, pay attention, look up please. Let me simplify. X squared minus 6x. What is negative 6 divided by 2? What is negative 3 squared? 9. So I bring this down, 16 plus 9. Can I simplify here anymore? No. How about this side? Yes. So I'm going to simplify one more time. X squared minus 6x plus 9 equals to 25. We just finished step 4, which is completing the square. Copy that, please. Alright, let's see. So far the process. Here it goes. Step 1. Was it in standard form? Yes. Check. Step 2. Divide by the leading coefficient. What was the leading coefficient? 1, so I divide and it gives me that. Eliminate the constant. It was negative 16, so I added 16 to each side. That left a gap here. Step 4 was to complete the square. What did I do to complete the square? Well, I took the b, which is negative 6, over 2 squared, and I did that to each side. Simplified and simplified. Next, I'm going to go to step 5, which is to factor. Writing utensils down, look up to the screen. Now, looking at this, I can factor by doing what? Yes? However, now check this out. Focus, please. What did we just do here with all this process? Complete the... So what does that tell you about this? This is a perfect... What other method can we use to factor this one? If it's a perfect square. Everyone? Square root of the first, which is x. Square root of the last, which is 3. Sine of the middle is minus, and this is squared, equals to 25. We just did step 5. Copy that, please. From the corner. Now, for the entire process, there's more steps, but I just wanted to keep it at 6, and you'll see right now what I'm talking about. All right? So, any questions on the factoring portion? We're good, right? All right, I'm going to go to the last step. Here it goes. The last step says, let's see, it says, take the square root, write 2 equations, and solve. All right. Take the square root, write 2 equations, and solve. So let me ask you this. Look up, please. Write your pencil down, look up. If I wanted to solve for x, that means I need to get rid of this squared. Is that correct? Yes. What is the inverse of squared? Of a squared? Okay, let's go through our operations. What is the inverse of addition? The inverse of multiplication. What is the inverse of a square? Square root. That's why for step 6 we start with take the square root. Whatever I do to one side, I do to the other. So pay attention to this part. Hold on. This cancels this. We're left with x minus 3. Are we there so far? Yeah. What 2 numbers multiplied give me 25? Positive 5. However, what other 2 numbers multiplied by itself gives me 25? Negative 5. So from now on, whenever you take the square root, we're going to write what? Plus minus 5. Here it goes again. Some of you lost it. Here it goes. Square root of 25 means what number times itself give us 25? 5 times 5. What other number by itself? Negative 5 times negative 5. Instead of writing each one independently, I'm just going to write plus minus 5. Does that make sense? Yeah. Alright, so check this out. Hold on. Let me finish step 6 before you copy. So I'm done with take square root. I'm going to jump right into equations, and I'm going to go to this step. Solve. Look at it. What do I need to do to solve for x? Add 3. Add 3. So I'm left with x equals 3 plus minus 5. Are we there so far? Next, write 2 equations. Okay. Why do I need to write 2 equations? Let me show you. X of 1, x of 2. This equation, 3 plus 5. What do I write for the second equation? 3 minus 5. Therefore, this is 8 and this is negative 2. These are my solutions. X-intercept, 0, and root. Copy that, please. Let's go. Bam. Copy that so I can go over the last couple of steps. Alright, so let's see. So we got standard form, divide by the leading coefficient, eliminate the constant, add b over 2 squared, which is completing the square. From there we did factoring. And how do we factor? Doing the square root method for the first and the last, because we know it's a perfect square trinomial. From there we did the last three steps, take the square root, we solved for x and we wrote two equations. Those were our solutions, x-intercept, zeros, and roots. However, we're not done. Even though I didn't write the step up there, what is the other thing that I asked you to do last night for the home plate? Graph. So let's do the little graph on the side. Once again, the graph is so that you can see everything, how everything is connected, and why we look for that. So here we go. What is my first root? 8. What is my other root? -2. And what is my y-intercept, everyone? -16. And we can get that because that's the constant of our equation. Or, what's another way of finding that? By multiplying the two roots, and that's how we get our y-intercept. So we graph that going from left to right, and it looks something like this. Bless you. There you go. Looks like Rudolph, yeah? Rudolph the red-nosed reindeer. There it is. No? What else did it say on the problem? It said what? Check your answer. Yay! So, to check our answer, we need to write our equation how many times? 2. X squared minus 6x plus 16 equals 0. X squared minus 6x plus 16. Is it plus 16 or minus 16? Oh, my bad. Minus 16. I did that to see if you were paying attention. Equals 0. So what values am I substituting in there, guys? So 8 squared minus 6 times 8 minus 16 equals 0. And then -2 in parentheses squared. -6 times -2 minus 16 equals 0. Alright, let's see. And by the way, this is our check. 8 squared is 64. -6 times 8, that's -48 minus 16 equals 0. Combine like terms, what is -48 and -16? -64. So we have 64 minus 64 equals 0. So this is 0 equal to 0. Is that true? Yes. Go to the second one. -2 squared is 4. -6 times -12 and -2, that's positive 12. Bring down the -16 equals 0. What is 4 plus 12? 16 minus 16 equals 0. So that's 0 equals 0, and that's a check. And we're done. Man, look at that. Beautiful. Look at that. Right there. eBay. Here we go. Bam. Yeah, we're done with example 1. Let's go to example 2. We're ready for example 2? Yeah. Alright, here we go. Example 2. For example 2, you don't have to copy the instructions. Just copy the equation. X squared minus 4x minus 12 equals 0. X squared minus 4x minus 12 equals 0. I'm going to leave the steps here on the side like this so that you can follow that process and see if you can do that by yourself. Okay? Copy that and go. Alright, let's see. Is it in standard form? Yes. Step 2, divide by the leading coefficient. What is my leading coefficient? 1. So I write everything over 1, and then I get x squared minus 4x minus 12 equals 0. Step 3, eliminate the constant. What was my constant? -12. So what do? Plus 12 plus 12. Therefore we end up with x squared minus 4x, leave a space, equals to 12. Hands if you get up to right there. Okay, good. Next, I'm going to complete the square by doing b over 2 squared. What is b right now? negative 4. So I add negative 4 over 2 squared to each side. Negative 4 over 2 squared. Let me simplify this. X squared minus 4x plus 4. Is that correct? 4 equals 12 plus 4. Can I simplify a little bit more? Yes. X squared minus 4x plus 4 equals 16. Hands, have you got it to right there? Okay, good. Next, let's factor. How do we factor it, knowing that this is a perfect square trinomial? Square root of the first, x. Square root of the last, 2. What is the sign of the middle? Minus, and all this squared equals to 16. So far so good? Next, take the square root. Why? Because we need to get rid of this squared. But whatever I do to one side, I do to the other. This cancels that. I'm left with x minus 2 equals what? Plus minus 4. Hands of you up to right there. Okay. From there, solve for x. Plus 2 plus 2. X equals 2 plus minus 4. Let's write our two equations. X sub 1 equals 2 plus 4. And x sub 2 equals 2 minus 4. So my roots are 6 and negative 2. Solution. X-intercept, root 0. So many things, how comfortable you are with these so far? 4 or 5 3s, 4 or 5 3s. Okay, we need practice, right?
Yeah.
So, let's graph this just to make sure that we got all the information for the graphing part. Where is it at? So my roots are 6. Where does that go? 6 goes right there. And the other one is negative 2. Negative 2 is right there. What is my y-intercept, everyone? Negative 12. And then graph from left to right. And you know how to check, yeah? Okay. We good? Okay. Let's do one more. Ha 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 ha. Let's go. Example 2b. X squared minus 4x minus 6 equals 0. This one you should be able to go a little bit faster now. See if you can do that one by yourself. However, I'm going to stop the video for those that are watching. And our home plate for tonight is on page 593. Only numbers 15 through 23. Michael Jordan. Have a good one, guys. Enjoy your home plate. See you guys tomorrow. Bye.